In this video, we're going to talk about the intermediate value theorem, which is something you'll probably discuss in a pre-calculus or math analysis type class. So the intermediate value theorem states that f is a polynomial function. If f of a and f of b have opposite signs, then there exists at least one value between them, which we'll call c, such that f of c is equal to 0. And as an example, we're going to take this function f of x equals x squared minus 5x plus 4. And if we plug in 0 for x here, this term goes to 0 and this term goes to 0, so we can quickly see that we have 4. But if we plug in f of 2, we get 2 squared, which is 4, minus 5 times 2, which is 10. So that's going to be 4 minus 10 plus 4, which is going to give us negative 2. That tells us, by the intermediate value theorem, that there is some 0 between 0 and 2 here for x. So we can factor this really quick and see our zeros. So if we want to set this equal to 0, we get x squared minus 5x plus 4. And then we can factor this. We know that 4 splits into 1, 2, and 4, because those are the factors of 4. And 1 and 4 combine to make 5. So we can really quickly see that this factors like so. X minus 1 times x minus 4. And so we can see our zeros are as follows, 1 and 4. And this value of x equals 1 satisfies our intermediate value theorem that we found over here. It satisfies this box in orange, that there has to be a 0 between x equals 0 and x equals 2. That 0 is x equals 1. Okay, let's look at a couple more examples. Okay, so we have our next example written here, and this example wants us to prove that this polynomial, x cubed minus 5x times x squared plus 3x plus 6, has at least 2 positive zeros. That means we're probably going to need 4 different values, because we're going to need to prove that there is one possible 0 using values of a and b, and then another positive 0 with values d and h. Okay, so let's get to that. Let's start taking values of this function and see where we go. So let's start with x equals 0. So if x equals 0, this term goes to 0, this term goes to 0, and this term goes to 0. And we're just left with 6. Okay, so that's pretty easy. Now let's look at f of 1. This is going to be similarly easy because all of these x's are just going to turn to 1s. 1 minus 5 plus 3 plus 6. That's going to give us 5. And now let's take the x equals 2. So let's do f of 2. And that's going to give us 2 cubed, which is 8. Minus 5 times 2 squared, which is 4. That's 20. Plus 3 times 2, which is 6, and plus 6 here. But 8 minus 20 plus 6 plus 6 is in fact 0. So we have our first 0. We have our first positive 0 that it asks us to find, but we'll keep going. Let's find f of 5. That's going to give us 125. That's 5 cubed. Minus 5 times x squared, but that's also going to be 125. So that's 125 minus 125 plus 15 plus 6. So that's 21. So plugging in 3, we get 27 minus 5 times 9, that's 45. Plus 9, that's 3 times 3, plus 6. And that's going to give us, let's see, 27 minus 45 is negative 18, plus 9 is negative 9, plus 6 is negative 3. So there's another value between 3 and 5 because this term is negative and this term is positive. There has to be some value between 3 and 5 for x that results in a 0. And that's enough for now.